Okay, in my previous video, we talked about the basic architecture of a neural network, right? And we have seen like what are the different components over there. Now, in this video, we will talk about tensors. Now, tensors are basically very much important to the deep learning because it's the basic data structure of any neural network. So that means the input data and the data flowing from different hidden layers to the output, everything you need to represent with tensors over there. Okay, so that's why learning and understanding what tensors are and what kind of operations we can do on the tensors is much important over here. Okay, so tensors are very generic term because this was initially developed by physicists, okay, for different problems related to the physics. Even if you see the Einstein field equation, so over there you will see the lot of applications of tensors over there as well. Okay, so tensors is a vast topic and it can be defined in various ways, but we will concentrate on tensors and its applications related to the field of deep learning only. Okay, and in deep learning we will think about tensors as a containers of the data. Okay, it's a data structure over there. Okay, so why we need to study tensors? So as I said, we need to transform the input data, let's say our text, images, videos, etc., into a format which can be easily understood and processed by the neural network. So that's why tensors are very much important. And if you see it, like, it is so important that Google has actually named its product TensorFlow with its name only. Okay, so that's why we need to understand thoroughly tensors over there. And in this particular video, we will try to see what are the different kinds of tensors are available. Maybe in the next video, we will talk about the different kinds of operations we can do on the tensor. Okay, now let's start. So we will, as I said, we will talk about the different kinds of tensors over here. Okay, so the first is the very basic kinds of tensors is called vectors. Now, while we try to understand tensors, we need to think about three things over there. Okay, one is the dimension, another is the shape of the tensor, and another is the data type. Okay, so first, the main important thing is the dimension of a tensor over here. Okay, based on that, different types of tensors are formed, and we will also see like how different kinds of data we can represent with different kinds of tensors over here, or different dimensions of the tensor over here. Okay, now initial and the most fundamental or most basic one is the vectors over here. So we will start with an example over here. Okay, so let's say we have housing data, and in our data we have a single house data, and if you see, we have the number of bedrooms, number of floors, the area, and the price over there. Okay, and we have a data of a single house over here. So how can we represent this particular data? We can represent this particular data in a, and if you see like this, for the single house, this is the only one dimension over here, right? This is the, if we just look at this particular view over here, so this is a data about a house where we have 4 bedrooms, 2 floors. This is the square feet, and this is the price over here. So we can represent the data something like this one, right? An array of numbers over here, and if we just place them column wise, so it will look something like this one over here, right? So where the first number is the number of bedrooms, my second number is the number of floors, my third number is the area value, and the fourth one is my price value over here. Okay, so this is nothing but a vector. Okay, it's a single dimension because the dimension is the house level details over here, right? So this is nothing but called a one-dimensional vector over here. Okay, and we can represent this with a array, simple array over here. We'll see an example of how to represent this one in a NumPy as well. Okay, but generally in mathematical way we can represent a vector something like this one. So if we just arrange the element column wise, so it will look like something like this one. Even vector can be row vector as well, but mainly we will be bothering about the vector which where the elements are stored as a column wise. Okay, so we saw what vectors are. So now let's take an example in NumPy how we can define this particular vector over here. Okay, so if I go to Spider, we will just do an import NumPy as np over here. Okay, now as I said, we will try to study three things over here for any kind of tensor over here. What is the how to define the tensor basically. So now this is how we can define a vector over here. Okay, which is nothing but a one-dimensional tensor. So it can be thought of as a simple NumPy dot array over here. So in any programming language we have the concept of array over here. So that's nothing but a vector. We can think about it. Okay, and the values are the same values, let's say for the house. Okay, so I'll just copy from whatever we have in our housing data over here. Okay, so if I just define this one, so x will be a one-dimensional tensor. And how I defined it, how I know it, so if I just print it out, okay, three things is the dimension. So if I just print the dimension, and also I print the shape of the tensor, and the data type, let's say. Okay, so dot format. So how you will print the dimension, so if I just say x dot ndims, okay, ndim, so that's my dimension. And for shape it will be x dot shape, and for data type it will be x dot d type. Okay, so that's it. So let's print that out and see. It will be import. Okay, and if you see for this particular vector, the number of dimension, it is showing up as 1. So that's why we are calling it a one-dimensional tensor. Okay, and shape if you see it over here, like the 4, that means the number of elements we can see in the column wise, and it do not have the second element over here. But when we'll move to the higher dimensional tensor, we will see the shape over here, and data type, it is saying like what kind of data we are storing it over here. Okay, so tensor is basically a very common term for a vector, matrices, and other higher dimensionals over here. So when we'll talk about some other higher dimensional tensors over here, we'll maybe try to understand this concept more thoroughly over here. Okay, but we have started with the vectors over here, which is nothing but a one-dimensional tensor over here. Okay, now let's move on and let's see what are the different other dimensional tensors over there. Now let's talk about the two-dimensional tensor, which we can represent with a matrix. Okay, so we will go by the similar examples whatever we have seen in the vectors. Okay, so over there if you see, now we have two houses data. Okay, for the house 1 we have this features, for house 2 we have these features over here, right? So why it is two dimension? Because if you see this particular view, you will see a single house details, right? And if you see this particular view, you will see for the all house details. And if you see, like, this particular view actually represents the feature level for each and every house as well, right? So that's why, like, this data are actually two-dimensional in nature over there, right? And in similar way, whatever we have done for the vectors, okay, we can represent this particular data in similar fashion for house 1, and for house 2 we can represent with single vectors over here, right? So this is nothing but a house 1 vector, and this is nothing but a house 2 vector over here, right? And if you see, like, this things is nothing but a matrix over here, right? So that's why it is called a two-dimensional tensor over here. And if I just see like how we can define a normal matrices, so there would be a m rows and there could be a n columns over here, and individual element we can access it something like this one, right? Represented is something like this one in mathematics, right? Like if I just see the first row, first column element, it will be a11, something like this one, right? So these are nothing but a matrix representation, which is nothing but a two-dimensional tensor over here. So if I just go to Spider and try to define the similar way, so how you will be defining? It will be defining the arrays of array. Okay, so let's see that. So how we can define a multi-dimensional or two-dimensional array over here in the NumPy? So we will say, so if you see, this is the first house details, right? And if I just give the second house details, I'll just copy it so that we can save time over here. Okay, this is my second house array over here. So if I just put this whole stuff in another array, so that means whatever I am saying is for my array, okay, each and every element is also an array over here. If you see it, the individual elements are also array. Okay, I think this. Okay, so this will become a two-dimensional tensor over here. And if I just again print the whole stuff over here, okay, let's not save it. So if I just run it, for the first one we are seeing it's a dimension 1 over here and a shape 4 comma nothing, right? The second one, if you see it over here, the dimension is returning as 2 over here, right? And the shape is, if you see it, 2 comma 4 over here. Okay, so for individual houses we have 4 features. That is how we can basically see it. Okay, and the data type is what kind of data you are storing it over here. Okay, so this is a two-dimensional tensor over here, which we can represent mathematically in a matrix format. Okay, so let's see how a higher dimensional tensor looks like. So if you just analyze this two-dimensional tensor over here, if you see this particular view, this is the house level view over here, right? And if you see this particular view over here, so this is nothing but the feature level view, means the number of bedrooms, floor. If you see the 4 and 3, this particular row over here, basically the row level details, this 4 and 3, the first row is basically the bedroom, number of bedrooms, right? The second row is basically the number of floors, like this one. Okay, that's why it is a two-dimensional tensor over here. Now let's talk about the 3D tensors. Okay, so now we will try to start with the similar data whatever we have discussed for the 2D tensors over here. Okay, with the addition, if you see it over here, so there is an extra column I have added, is called month. So that means we are basically our input data is for each and every house. We have a time as well. That means for each and every month, what was its price. Okay, so that means we have a time factor over here. That means it's basically nothing but a time series over here, right? So if I just talk about the dimensions, we still have the individual house level details, right? We still have for different houses details, we have multiple houses, that is another dimension, right? And we have our third dimension called the month or the time over here. Okay, so any kind of time series data generally in the neural network we represent with a 3D tensors over here. Okay, now if I just talk about the structure of a 3D tensor, so we can see something like this one. So if I just see in the 2D tensors, we have a matrix, right? In the 2D tensors, which nothing but a matrix over here, we can represent it, right? So we can represent a single house data in a matrix format, something like this one, right? For each and every month, what its details over here. Okay, now if we just stack these matrices for each and every houses, it will look something like this one, right? So this is nothing but a 3D tensors over here. So over here, if you see individual houses with the time details, and for different matrices we have the different houses details with their time level details over there. Okay, so this is the 3D tensors over here. Okay, and if I just visualize it as a 3D tensors, it is nothing but we can thought of as a cube of numbers, right? Okay, so in similar way, in the NumPy, how you will be defining a 3D tensors. So over there, so our as we have seen for the matrices, each and every element of that array was another array, right? In the 3D tensors, what will be happening? Each and every element of that particular array will be another matrices over there, right? So which is nothing but, if I just if we just talk about in current examples, individual house details with their different time frames, right? So let's see that. So I'll just try to copy that similar stuff over here. So this is my 3D tensor. Okay, so you can save some time. Okay, and if you see it over here, like the individual houses details are, this is my array for the first house. Okay, and that time I actually converted to the epoch format. So basically in the tensors, mostly we save the numeric values. Okay, and if you see the elements of the tensors, mostly we save the numeric values. It is very rare that we save text values over there. So that's why I converted that particular time into epoch format over here. Similarly, for the same house, this is the second array over there, right, for the second time frame, and I just put it in another array over here. So this becomes my first matrix over here, right? And similarly I did for the second matrices over here as well, and I put this whole two matrices in another array. Okay, so that's how it's becoming a 3D tensors over here. So if I just run it now, so if you see for the third one, the dimension is 3, the shape is 2 to 5. Okay, and the data type is integer 32 over here. Okay, 5 means, if you see, like there are 5 elements for each and every array. That means if I just remember this 2 to 5 over here. Okay, so that means we have 5 elements, and for individual houses we have 2 rows, that's why that 2, and we have 2 houses over here, that's why another 2 over here, that's why 2 to 5. Okay, now let's talk about more higher dimensional tensors over here. We will move to 4D tensors over here. Okay, now 4D tensors, I think the best example will be how we can process images in the neural network and how basically represent images in the neural network over there. Okay, so let's say we have an image over here. Okay, so what are the different features it has? It has some width, it has some height, and another important stuff it has is the color width. Okay, so if you see any individual pixels over here, so it has a color depth over there. Okay, so you will see, search in Google, maybe you will see like the 8-bit, 32-bit, 64-bit color depths are there. Okay, so that, so if I just represent this whole stuff, okay, in a intuitive manner, so it will look something like this one over here. Okay, if you see, we have the height, this is one dimension, we have the width, this is another dimension, and we have the color depth. Okay, so this is another dimension over here. So a single image we can represent as a 3-dimensional tensor over here, 3 tensor over here. Now think about it, when we process in a deep learning neural network, right, we generally do not work with a single image, we work with multiple images over there, right? Like this one, we have another image which will have the similar kind of which can be represented as a 3D tensor as well over there, right? So that will becoming the another dimension over here. Just like our housing example, when we talk about a single house, we can represent it with a vector. When we talk about multiple houses, we can represent with a metric, which is nothing but the 2D tensor over here. Okay, so here the individual images we can represent with a 3D tensor, but when we deal with multiple images, so it becomes a 4D tensors over here. So that means if you see it, like in every scenario, the sample is becoming another dimension over here, right? The number of samples over here. Okay, so this is nothing but a 4D tensor, and how we can represent or how we can visualize a 4D tensor. So 3D tensor, we talked about a single cube over here, right? This kind of 3D structure, right? So this is nothing but a single image. So when we have multiple images, we will just stack our cubes on top of it, right? That is how we can visualize it in the a 4D tensors over here. Okay, now let's move on to another higher dimensional tensor over here. So if you just see the pattern over here, right, we can just stack it and add more dimensions over here. Okay, let's talk about the 5D tensors over here, or 5-dimensional tensor over here. Okay, and 4D tensor, we can define it in a similar fashion in the NumPy as well. So I am not going to that level because it will be various so many arrays we have to create it over there, but I think you got the idea over here, right? Now 5D tensors are basically used when we process videos. Okay, so let's see how, for a typical video, let's say we have a YouTube video or any videos over here. Okay, now what a particular video is basically, it's basically essentially a list of frames we can think about, right? So stacking one by one, right? And each and every frame is nothing but a picture or image over there, right? So each and every frame, we can think about it as a 3D tensors, as we have seen in previously over there, right? Now when we have multiple frames, we will be representing the data as a 4D tensors, as we have seen in previous video, right? Now, sorry, in the previous slide, right? Now when we have multiple videos, in that case what will happen, each and every video will be a 4D tensor, and when we have multiple videos, the whole step can be represented as a 5D tensors over here. Same concept. Okay, so you have 5D tensors. Now how we can represent or how we can visualize a 5D tensors over here. Okay, so here it is. So individual blocks is my frames, right? So we have multiple frames in my video, right? So this particular structure represents a single video over here. So when we have multiple videos, we'll be basically creating another this kind of structures over here, right? Okay, so this is how we can visualize it 5D tensors over here, and we can go any further, any higher dimensional tensors over there. Okay, the concept will be similar over there. Okay, but generally, like most of the scenarios, 5D till 5D tensors should be fine. Okay, so what we have learned over here, like from 1D tensors to the 5D tensors, how we can represent and why we are representing that one, right? And how we can create the similar stuff in the NumPy as well. And if you see in the individual array elements, right? So we are writing this 4, the number of bedrooms, number of floors, 4, 2, right? So these are nothing but the scalars over there, right? So if I just go to NumPy again, so this is how we can create a scalar. So it's a fancy name, but it's just a number, right? So if I just write x equals to numpy dot array, and we have a single number, let's say 6 over here. Okay, and if I just print the similar stuff, our dimension, shape and data type, let's see what it is printing over here. If you see for the last one, the dimension is 0 because scalars do not have any kind of dimensions over there. Okay, it do not have any shape. It has the data type definitely, but it do not have any kind of shape and dimension. That's the difference between a scalar and the other tensors one as well. Okay, so scalar we can think about as a 0-dimensional tensors over here. Okay, and if you see like for individual array elements, this 2 1 0 0, this 4 2 are nothing but a scalar over here. Okay, so hopefully we got a fair idea about what tensors are. Okay, and in the next video we'll talk about the different operations we can perform on the tensors. Okay, see you in next video.